Hey, it's Sebastien, energy analyst at Gridcog, and today we're diving into the economics of behind-the-meter battery storage for a C&I customer, part 1. In this first chapter, we'll analyze how a battery can reduce a business's energy supply costs without ever exporting to the grid. A battery follows 3 main strategies to reduce supply costs. The first and simplest is tariff arbitrage, charging when energy prices are low, typically at night, and discharging into the site load during peak pricing. This is also commonly known as load shifting. The second approach, which can also be combined with the first, is self-consumption of solar or wind energy. This involves storing surplus energy generated on-site for later use, rather than curtailing it or selling it for a low feed-in tariff. The final strategy is reducing demand charges, a charge paid to network operators for using their infrastructure. Since these charges are often determined by peak demand, reducing peak consumption can lower the demand charge for the entire billing cycle. This is also called peak shaving. To illustrate these 3 approaches and analyze their effects, let's fire up the Gridcog software. First, we create a baseline scenario. With a typical supermarket load consuming around 470 megawatt-hours per year, we add 300 kilowatts of rooftop solar generation, ensuring some excess generation at midday. In the commercial model, we set up an unbundled tariff. First, we add supply costs, composed of time of use rates, varying from 6.7p per kilowatt-hours at night to 8.2p per kilowatt-hours during the day. Next, we add network charges for distribution and transmission, which include time of use rates and the demand charge. Lastly, we include non-commodity charges. With the baseline set up, we now duplicate the scenario and introduce a 250 kilowatt-hour, 2-hour battery, keeping everything else the same. Our simulation results are visualized in this cash flow chart. The battery cuts yearly energy costs by £10,800, a 19% drop from the baseline. Network cost reductions, in red, contribute 35% of savings, while supply cost reductions, in blue, make up 65%. So nearly £11,000 a year in savings sound pretty decent, but batteries are still pretty expensive assets. So is this a good investment? If we assume a battery capex of £350 per kilowatt-hours, then we get a simple payback of just over 8 years. This may be viable for businesses prioritizing energy security or emissions reduction, but for many, the payback is too long. Remember, this is only half the picture though, and in part 2, we'll explore additional revenue streams like wholesale arbitrage and ancillary services to shorten the payback period. It's important to note that every site is unique. Different load profiles, tariff arrangements, grid connection constraints, and the performance of on-site generation all significantly impact the economics. This makes tools like Gridcog essential in making informed decisions for renewable energy investments. Check out the Gridcog website and connect with the industry team to learn more. Thanks for watching.